Alrighty friends, so here we are going to do integration by partial fractions. So we have this problem, and we have, okay, so our first problem looks like this. And when you're going to do this, it would help to factor the problem, so the original integral. So let's go ahead and factor 5x minus 3. That bottom's going to factor into x minus 3, x plus 1. dx. Now, you want to do kind of an aside at this point, because I would like this to be two different fractions. So your aside is going to be this, 5x minus 3 over x minus 3x plus 1 equals, often we pick a and b, a over x minus 3 plus b over x plus 1. And let's go ahead and multiply through by both those denominator pieces, the x minus 3 and the x plus 1. So that gives us 5x minus 3, and then x plus 1 here, and x minus 3 here. If you're confused, if I multiply through, that one goes away. This one gets an x minus 3 and an x plus 1. Those cancel. This one gets an x plus 1 and an x minus 3. Those cancel. Hence my orange line here. You, at this point, have two different options. Option 1 is to plug in. So if x is negative 1, then on the left I'm going to have negative 5, negative 8. And on the right, the a part goes away. The b part becomes negative 4b, which means b is 2. And then if x is 3, then we have 15 minus 3, which is 12. The a part is 4a, and the b part is 0. So that means a is 3. Now, if you're wondering where I got negative 1 and 3, it's simply what makes in the parentheses here 0. Now, a second way of doing that same idea is, if I go back to that orange line right here that I just kind of crossed out, let's collect like terms. This will give me ax plus a plus bx minus 3b. So 5x minus 3, you have ax plus bx plus a minus 3b. And now let's just kind of group things up. So 5x minus 3, a plus b x, and then a minus 3b. Now, match things up. Your coefficient here has to match your coefficient here. So 5 equals a plus b, and then negative 3 equals a minus 3b. And you can solve this system. So maybe I'll subtract the bottom piece from the top piece. And I'm going to get 8, a minus a is 0, b minus 3b is 4b, which means b is 2. b is 2. And then going back to this equation, that means a is 3, which is what I got above. So either way works. The top one that I wrote in green right up here will often work if you have kind of basic ones where you don't have repeated factors here, and you have some sort of linear constant on the top. Okay, now I just move some things around to make my life a little bit easier, so I can rewrite that integral as, let's see, a is 3. So 3, and a had x minus 3 underneath, and then b is 2, and b had x plus 1. Now, my benefit here, yeah, I'll be a little more long-winded on this one. My benefit here is I can write this as two different integrals. You don't have to take this step. You can just kind of do each integration part separately. But I'm going to show you how you could think about it in case you're confused. So I broke that into two different integrals. So now you should realize that's a natural log thing. So the natural log of x minus 3. Note the absolute values there. That's for domain issues. And then the absolute value of x plus 1. Both those are linear factors, the x minus 3 and the x plus 1, and the derivative of both those is 1. Therefore, I don't have to worry about chain rule issues. And then I have a plus c. And that's it for my first one. Let's do another one. Our next one is 6x plus 7, x plus 2 squared dx. So we're going to have to do much the same process as we did last time, but there's a little bit of a tweak here. See how we have that repeated factor on the bottom? That means we have to try to figure out an a and a b value just like we did before, but it's going to be written different. A over x plus 2, b over x plus 2 squared. Now when you multiply through, you're going to get 6x plus 7 is a times x plus 2 plus b. And now you're going to have, I'll do it the second way, 6x plus 7, that's going to be ax plus 2a plus b. And this is going to mean a is 6 and 2a plus b is 7, which means b is negative 5. So I move those things out of the way, and now I have, my original integral was there, but now I'm going to have a over x plus 2 plus, maybe I should say minus, b over x plus 2 squared dx. Now if it helps, I'll do this again. If it helps to write it as two different integrals, go for it. So that's 6, kick the constant out, x plus 2 minus 5. I'm going to write that as x plus 2 to the negative 2. And now that's going to be, that's a natural log, so 6 ln x plus 2. Again, the derivative inside is 1, so no chain rule issues there. And then minus 5, x plus 2 to the negative 1. I need a power rule piece, though, so I need a plus 5 plus c. And our next one, which I'm going to call our last one, is integral 2x cubed minus 4x squared minus x minus 3 over x squared minus 2x minus 3 dx. Now, the degree of the top is bigger than the degree of the bottom, so I'm going to need to divide first. So 2x cubed minus 4x squared minus x minus 3, x squared minus 2x minus 3. So to get from x squared to 2x cubed, I need a 2x. I like to line it up above its friend, the one it looks like. So that's going to be a 2x cubed minus 4x squared minus 6x. I need to make sure I subtract down. 2x cubed minus 2x cubed is gone. Negative 4x squared minus negative 4x squared is also gone. And then negative x minus negative 6x is 5x minus 3. Well, I can't possibly get x squared to get to 5x by using some sort of polynomial. So I'm going to say plus 5x minus 3 over x squared minus 2x minus 3. Wait, that 5x minus 3 is familiar. So now my integral looks like this. The integral of 2x dx plus the integral of 5x minus 3 over x squared minus 2x minus 3 dx. 2x, that's just x squared. And then the 5x minus 3, that was the first problem I did. So that was 3 times the natural log of x minus 3 plus 2 times the natural log of x plus 2 plus c. And we are done. Oops, by x plus 2, I mean x plus 1. There we go.